Was out for a week. Just came back yesterday night.
I see. I see.
Hey, Sandeep.
Hi. How's everyone doing?
Tired but excited. I just got done with the job,
I
but
see.
at the same time excited to learn.
I see. Wonderful. Wonderful. Perfect. Perfect. All right. All right. So before we start, all the notebooks I have put into a GitHub repository. Okay. So you can take a look at the notebooks. Oh, it's not post. What? I just committed. Okay, let's see. Let me share my screen and then talk. Okay, so yes. So what I've done is I have put our all the notebooks into this notebook, this repository, and this is sorted by date wise, 4th May, 24th May, then sorry, 4th May, 11th May, and then 17th May, and then 24. Okay. All right. So let me share that repository name with everybody. And where is that? Here. Chat. Yes, Sammy. Good thing devs are fine, even they commit. Yes. Okay. All right. All right. So where were we? Keep your cameras on, make the class lively. Okay, I will be committing in this repository only. You can see my screen, right? So I've also added the repository by Neil. He had put some answers, so I've just put it there. Okay, and if he has an objection, I'll take it offline, remove it. Okay, but yeah, you can. What you can do is you can fork this repository and put your stuff into it. Okay, just put one more notebook of yours with the solutions. Okay, no need to modify the existing notebook, just create one more notebook. Okay, so whatever work we are going to do in this class, I'll just keep on adding repositories into this, those notebooks into this. Okay. Yes. Music is just too much lively. Okay. Perfect. Let's start now. So where were we? On the last time, I'll just close this. Yeah. This is my folder, and last time we met was 24, right? But afterwards, didn't we have another class? No, we did not. Okay. We did have another class, right? After 24th May. On 25th May, we must have had the class, right?
Yes, 25th as well.
Yeah, so where is 25th? 26th May, I can see. 18th May, I can see. This is not your repository. This is not yours. This is from the other class. Okay, I'll take a look at what happened to that notebook. Where did I make that?
I think for 24th or 25th our time, you use the same notebook again
Oh, yeah,
and then
yeah.
send it back.
Yeah, I just added things into this here.
Yes, yes.
Okay. All right. All right. This is good. So we'll just open this repository from here, 24th. Yes. Okay. So we had ended this class with the blue score. Okay. Okay. Yes, we were in the middle of a very interesting discussion. Okay. So what we had done so far, okay, I'll again just put the stuff into this notebook itself. Okay. So everybody is clear about how to create a Faircoin? Yeah. With the two faces and n faces. Okay. Two faces, three faces, and n faces. Everybody's clear about it? Or you want me to finish it? Let's just see. Right. So with two faces, what was the right? Two face coin. Okay. Two face coin, and we'll say, okay, we'll say okay, from random import random and r equals random if r less than 0.5, okay, return 0, else return 1. Yeah, this was all clear, right? So if you run it, it works fine. All right, done. Okay, now if I have to do the n phase, right? So we'll say n phase coin. This we had done last time only. So basically, if you have n phased coin, okay, n phased coin, what do? You basically what you do is you divide the number line, or what you do is you basically do things like take the number n, sorry, r equals random. So it will come somewhere between 0 to 1, right? So what we will do is we'll break this, we'll convert this number line into 0 to n. Okay, 0 to n. And what we'll do is 1, 2, 3, something like this, right? So we'll just say r into n. Okay, so we are just saying r equals r into n. So what we did was we make the random number from 1 to n. So if let's say there are 6 faces, so r will be if n is 6, then r will be between 0 and 6. Correct? Is everybody okay? No? We are making n phase coin, right? Now what we can do is we can take the integer part of it. Okay, meaning if the random number comes like 1.2, we will return 1. If the random number comes like 0.1, we will return 0, something like this, right? If it comes like 3.4, we will return 3. Make sense? So you can just say return integer part of this. Okay. So that's my random coin generator. Is it okay? N face dice or n face, right? Mm, okay. Is it making sense, everyone?
Yeah. Sandeep, I have tried another way to do it. Maybe you can copy paste, and I just would like to know your feedback on this program.
Okay.
Will this give an even distribution?
I think so. Should I try? For I in range, for I in range, say 100,000. Okay. And I would say, I'll just create a dictionary. Okay. And how should I make it quickly? I would say dictionary I'll talk about later. You can think of it right now like an array. Okay. Or let me just say 0 times n. Okay. That's correct, right? So n length 0 times n. So I'm saying d of n face coin. Okay. And then I can just print d. Okay. All right. What happened to this? N is equal to 10. Okay. Oh, it did not work. No, it did work. So almost, right? So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The only thing that I'm seeing here is, okay, the last one is always less than, a little lesser. Only the last one is lesser. That's what I'm seeing. No, it's okay. Last one this time got okay. All right. So I think this is good enough, right? This is good enough. So what I did here was this. First, I created an array. Containing only 0, 0, 0. Okay. So this is cool thing to know about Python. If you say 10, it'll become like this. Okay. So it basically make an array of 10 elements. Okay. Make sense?
Yes, yeah. We discussed this last time, yes.
This is okay. This is all right so far, right? Any doubts, any questions? I'll just take a look at somebody's code.
In the input 5, actually, where you define this n face underscore coin, what is this 0 hyphen triple hyphen 1? And in the input 5, Sandeep.
Okay, just give me a moment. I'm trying to copy Hemant's code. Okay. I'm trying to copy Hemant's code. Okay. All right. Which one? The
input 5. Yeah. What is this one?
This one?
0 triple hyphen 1.
Oh, this one.
Yeah.
Oh, no, I was just explaining something. Yeah.
Okay.
Yeah, it's good that you reminded.
Okay, calling n and then multiplied it by n times. Okay, that's fine. And then integer.
You can make it further shorter. This is probably, I can't go below this. More
Yeah.
than one.
Yes, that's fine.
Okay. Is it okay, everyone?
Yep.
All right. Okay. Yes. So this one is n buckets, n flips. Okay. All right. Okay. We discussed this idea last time, right? But though it will work, no doubt, but here there is only one problem. Okay. Basically here it has got one for loop, correct? It has got one for loop, isn't it?
Yeah, I mean, this is a main one which total from the complete times the bucket we need to about to create,
Yeah. So that means that it will take more time to do the calculation. Okay. So just everyone, the way we measure the accuracy, the way we measure the performance of a code is of course by measuring the time taken by it. Okay. But the question is, but the very important thing, very important discussion, everybody. Very important discussion. So usually the way we measure the code's performance is by the way of time taken by it and memory consumed by it. Okay. So how much memory it's consuming and how much time it's taking. Now, both these terms are very subjective. Okay. This varies, time varies based on processor. Like somebody's processor is faster, other person's processor is slower, somebody's hard disk is slower, or somebody's RAM is slower, and so on. So there are so many parameters, right? Time taken by, okay, by it, and the memory consumed. Memory consumed again is something that can also vary based on how much data are we processing. Making sense? So time taken by a computer and memory consumed, time taken by a program and the memory consumed are the main key criterias of a code being good or bad. Okay, but time could vary because of there are what all things can you think? Why, like what are the things that could cause time to be taken as more, right? It could be processor, it could be hard disk, it could be RAM, it could be how much data are we processing. Similarly, memory consumed is a function of how much data are we processing. Am I making sense? No. So like if somebody says that, okay, my code takes 10 seconds for this particular thing, and somebody like my code is taking 10 seconds and your code is doing the same thing, but it's taking 10 milliseconds, right? So your code is any day better. If it's doing everything exactly, then, right? But calculating time could not tell anything about your code because there are so many factors. It could be your computer might be having better processor, hard disk, and when somebody uses your code and says, hey, it's very slow, you can't say that, oh, it's because your computer is slow, right? So expressing time instead of in terms of, right, how it varies with data. Okay. This is called big O notation. Okay. Big O notation. Right. Now, what does it mean? It means how many iterations it is taking. Okay. Like for example, you have a list of numbers. Let's say this is my list of numbers. Okay. And I'm looking for, okay, I'm looking for I'm writing a function called search. Okay. This is my list of numbers. Okay. And right, to search. Okay. Very important part. This is extremely important. So everybody please pay attention. And somebody has the mic on. Can you just, yeah, keep it off? Okay. So you can see what I'm talking about. So let's say you're writing this nice function called search. It takes a list of numbers and number to search. So how would you write the code? Anybody? For num in nums, if number equals to search, okay, return true and return false. Okay. Are you able to see this like how it's doing the search?
Yes.
Now, this code, how many steps approximately it will take?
The size of nums.
Exactly. So basically, the time taken by search is a function of nums. Okay. Yeah. Is proportional to
Yes.
nums. Meaning, if nums was 10, nums was, let's say, 10,000. Okay. Nums was 10,000 and it was taking 1 millisecond. If nums becomes let's say 100,000, how much time will it take? Yeah.
10 milliseconds.
10 milliseconds. Correct. So this is basically called the order of n. Okay. If n increases, the n becomes double, the data becomes double, time taken becomes double. Is everybody okay?
Yes.
Okay. Counting steps, okay? We're just counting steps. And this is important because whenever you deal with any algorithm in machine learning or anything, every code's complexity is represented as order O(n). Okay.
Yeah.
Now, if you go back here, his code, though it has 2 while loops, but internal code is the one who is doing the job. So what's the order of complexity of this one? Order of n?
Order of n. Yes. Yep.
Yes. Okay. So his complexity of the code, Hemant's code complexity is order of n. Now, if you take a look at my, my code here, okay, my code, okay, here I am only multiplying. Where is my code?
Yeah.
Yeah, this
Yeah.
is the one. It's an unrecognizable. Okay. Yeah. In this code, there's no loop going on. It's just a random number being multiplied by another number. Okay.
We
So
will
this
convert
has
it.
got a complexity of constant time. Okay. Constant time, which means somebody's mic is on. Yeah. So this is the complexity of this is order of 1. We call that order of 1. You can see that there are no loops. If there was one loop, you could call it order of n. Are you guys okay?
Yes.
So this is order of 1 because there are no loops. This is order of n because there is one loop. Okay. And if let's say we are writing another function called handshake. Okay. It takes n number of people. It shakes hand with first person with everybody. Okay. So I'm going to say for I in range n, for j in range n, and it just prints. Of course, everybody shakes with the hand with it himself. We'll come back to that later. Okay. And we print I, comma j. Okay. So this handshake code will, let's say if I do it handshake 2, so it has printed 0, 0, 0, 1, 1, 0, 1, 1. If I say handshake 3, so first person is shaking hand with all the 3, second person is shaking hand with all the 3, and third person is also shaking the hand with all the 3. Okay. Of course, himself, and it's repeated. That is another thing. We'll talk about it later. Now, what is the complexity of this one? How many steps? If there are, for n number of data, how many times this print will happen?
N squared.
N square, right? So the complexity of this code is how much? Order of n square. Order of n into n. The first loop will run n times, and for each time, the next loop will run n times, so it will be n times n. Yeah? So total number of steps is n into n. So this is called order of n square. Is everybody okay with this?
Yes.
So Sandeep, how we can, I mean, when we start writing a logic, I mean, many times we don't care about the space and time complexity, right? Because we just would like to write a logic. So how we can
Yeah.
make sure that we also taking care of this part as well?
Yeah, very good point. Very good point. Just to keep everybody on the same page, always write the correct logic first. Okay. In the interview, even in the production environment, focus on writing correct logic and simple logic. Okay. If you just do a convoluted logic, what happens is that it becomes a mess. You can't solve it. Okay. So as simple as real thing that is happening, how would you do it with pen and paper? You do it that way. Okay. Don't overcomplicate. Don't try to memorize it. Just given a problem, just see how would you do it with pen and paper by manually without using a computer. If you are able to do it that way, what you do is then you basically try to replicate the same thing in the code. Okay. And yes, it takes a lot of practice, and you got to practice a lot in this.
Let's say in a program, you would like to check for time complexity and space complexity both, right? So which one we should go first, time or space?
See, you got to report both. Okay. But usually, though it might look like that these two things are opposite to each other, that if I memorize entire thing into an array, it will be fast. But in real life, what I've seen is the code, which is performing bad in the with respect to memory, is performing bad with respect to memory, also performs bad with respect to the CPU. Okay, so you should focus on both. Okay, the most important part is you should, how should I say? You should always look at ways in which you can minimize it. Okay, let's say something is not taking too much time, but it's taking too much memory. Then you have to be careful. Usually anything of the order of n square or above, okay, you have to re-evaluate. Okay, can you do it in a better way? Got it?
Hmm.
You have to re-evaluate. Okay. And yeah, that's the most important thing to do. Okay, so is everybody okay with order of n square and order of 1? Yeah.
And there's
O1,
order of log n as well, right, Sandeep?
yes.
Remember, I mean, it's long time back.
Yes. Yes. Okay. Are you ready for the login, everyone?
Yes.
Okay. All right. I'm going to write some code. You have to tell. Okay. And of course, I will not write the code as is. Okay. Yeah. So, I'm writing a code like print even. Okay. For I in range n, if, okay, let's say I'm doing, okay, let it be like this. Okay. I'm saying if I percent, okay, no. Right, I'm just going to say, I'll use while loop, I think. That's a little more tricky. That's why I'm using a while loop. I'm saying while, as long as I is less than n, okay, keep printing I. On every step, increase I by 2. Okay. So if I say print underscore even, if I say 4, it prints 0 and 2. And when I say print 7, it prints 0, 2, 4, 6. Okay. Is everybody okay with this logic?
Yes.
All right. What's the order or how many steps it will take in terms of n? This loop? What's the complexity? N by 2. So n by 2 steps, correct? N by 2 steps. N. So we never report n by 2. Okay. We always say that is order of n. Okay. So order of n, and if something is taking, let's say n plus 5, we again reported order of n. If something is, let's say 3n, it is called order of n. Basically, it's a linear time. Okay, linear time. Yes. So this is order of n. Okay, this is basically order of n. Everybody comfortable so far? Not too complicated, right? Or are you finding complex? You want me to explain again? Feel free to stop. Yes, everyone?
Can you explain again?
Okay. Which part? Do you want this one or the order of n in general?
Order of n.
Order. Okay. Okay. So when you are, let's say, running a loop like this, here, let's say we are searching for a number called, right? Let's say we wrote this code which searches for a number in a list of numbers. Let's say I'm saying 6, so it returns false, and it says 4, then it returns true. Okay, so this is what we are. So it takes the number, goes through the list. If it is found, it returns true. If it is not found, then it returns false. Okay. So we are saying search, and then there is a list of numbers, and I'm giving the another parameter. These are the 2 parameters I'm giving. Then what it does is it goes through this list of numbers using for loop for num in nums. If num is equal to search, it returns true. And once the whole loop is over, when this loop has finished, in the end, it returns false. Okay, so how many times will this loop run? It will run as big as your array is, right? If your array is having 5,000 elements, this loop will run. In the worst case scenario, it will run 5,000 times, correct? When it is not able to, it's kept on checking and it passed the end of the array and it would say, okay, not found. And in the end, once that loop is over, return false. So worst case scenario is that if nums has 5,000 element, this loop will run 5,000 times, correct?
If the first number itself is 4, will it still search for the entire array?
Good point. No, it won't. Okay. So we always think of when we are, it's a very good point. Whenever we are searching, if let's say we are saying search this, it won't go till the end, right? In that case, you can say, oh, it's all only order of 1. No. We always say that, okay, this is my search method. What is my worst case scenario? What is the worst case scenario? How many times? If your array, this list has, let's say, 10,000 elements. Okay. What's the worst case scenario?
All 10,000 times it will search.
10,000 times, right? So if the list has n elements, okay, it will, the worst case scenario is order of n, as in the n times, correct?
Yep.
And therefore, we call it order of n. Of course, sometimes we like to report the average case scenario. In this case, average case scenario is n by 2. If your number is found in the beginning, it is returned immediately. If it is found in the end, it returns in the end. So in that case, average case is order of n by 2. But we hardly ever talk about the average case scenario. We always talk about the worst case scenarios. Okay. So when we are coding up things, we always think about the worst case scenario complexity. Okay. Now it's clear?
Yeah.
Perfect. Perfect. So now you can say that in this case, this loop is going to run how many times? If we pass n, how many times will it run? N by 2 times. And n by 2 is also called order of n, not order of n by 2. Okay.
But then complexity is reduced anyways by 50%, right? Like n by 2. So why it's still being called as n by 2? I'm sorry, I'm trying.
No,
It
actually,
does not.
the way we only, just like in polynomials, we say this is a 3rd degree polynomial, 4th degree polynomial. Similar to that, we report this because this n by 2, n by 3 to n plus 5 or 5n doesn't matter much. One person's computer is higher and so on. It might be very different. Similarly,
Yep.
I'll show you. Okay.
Adding in constant number is fine, but when you multiply with any constant your complexity, it's normally increased by number of times, right? So,
yeah.
or decrease, I mean.
Yeah. So basically, it's a
constant
rough
number.
estimate. It's a rough estimate.
Okay.
It's a rough, just to, show you that, how will my processing vary with respect to the data? Okay. Is it linear? Is it square? Is it logarithmic? It is exponential. How is it? Okay. So basically the core concept of order is just to have this rough estimate. Rough estimate. I'm going to show you something that you'll be amazed. Okay. Now,
Sandeep, one question. You said that the code that you have written is order of 1, right? But it is using a method called random. But what is there inside random that we don't know? We usually don't check that, right? So how we will analyze that is order of 1?
Good question. So usually the random number is always going, irrespective of how many times, if I am calling random once or any number of times, it's going to take the same time, constant time, right? Irrespective of my n. It might be taking
Yes.
like 10 milliseconds, but it is not dependent on my data. Correct?
Loops or something.
Oh,
Yeah.
okay, okay.
No matter what n I am passing, like if you see this code, right? So, where is my code? Yeah, this one. So even if let's say n is 1000 or n is 20, okay, random will take the same time. Okay, and
Yep.
that means a constant. Okay, and this I'm multiplying that with the number. Okay, now you might say your point here, this is where you can say that when I multiply with a small number, multiplication ends quickly. Okay, if I multiply with a very big number, it will take long time. So yes, this is truly not O1. Okay, because usually underneath the way multiplication is implemented is that it is kind of, it is proportional to the number of digits in a number. Okay, and how do you count number of digits in a number quickly? By taking log of it. Okay, right? So how do you count number of digits? Wait, say 10, log of 10 is 1, log of 100 is 2, log of 1000 is 3, log of 10,000 is 4. So you see, it's kind of counting digits, right? So log is essentially for counting quickly the digits. Okay. And so basically the multiplication is a function of number of digits. Remember, how do you do the multiplication? You take one digit, multiply with all, then take another. So there's a for loop per digit happening inside, correct? There's a one for loop per digit. That means it is function of, this is going to be, right? Time will be proportional to number of digits in n. So ideally, as part of the computation, when we see multiplication, we usually report that it's a constant time. Okay, because it's a multiplication. Usually multiplication is implemented in a way that it is a constant time. But to be very accurate, to answer your question, it is still, it's not order of n, order of 1. It is actually order of log n. Okay. And log n is basically nothing but number of digits. Log is basically for counting digits. Okay. Now let's see. Let's see. Okay. I'm going to type some code and you have to tell me the complexity of it. Okay. Here. This is my function. It takes n, and what it does is it says I equals 0. Okay. And I'm saying, let's say I equals 0 while I less than n. Okay. It does something with the number and increases I with 3. Complexity? Yes. What is the order?
Order of n.
Correct. This is order of n. Why? Because order of n by 3 is same as order of n. Right? Okay. Now, now I'm just taking the same code and I'm saying this. Okay. I'm writing, let's say, a function called power. Okay. Integer power. Okay. Help me write this thing. Who will help me writing the the power. Okay. Basically, compute n to the power r.
Yeah.
Okay. How would you do?
Return n star star r.
And now you have to write your function. Okay.
You can just loop through r number of times
Okay.
and multiply n.
Correct.
And yeah,
Perfect.
n into n.
Tell me the code. I want to see the code. Return.
Product equal to 0.
What?
We'll
Product
assign
plus
product
0.
equal to 0. Then for
While
I yeah,
for I in
in
R,
R.
Okay. Okay.
Just product
Product.
equal
I think the
to
product should be
product.
1.
Product should be
The
one.
product should be 1.
Correct.
Yeah.
Hmm.
Product equal to product into n.
Product
I don't think this will work because range
Product
starts from
into power of n comma r minus 1.
Which
R minus
one?
1.
No, product equal to product. Sorry. Actually, it should return n into power of n comma r minus 1.
Let's just test it out now. So 10 to the power 1 is 10.
Doesn't range start from 0 though?
10 to
हाँ, ठीक है.
0. So far it's good. So far it's good. Let's see. Okay.
Yeah, ऐसे करो, इसी को वहीं लगा. Sorry.
You see this? So 10 to the power 0 is 1. 10 to the power 1 is 10. 10 to the power 2 is 100. Not bad. Can you guess what will be power of 0 to the power 0 as per this?
Zero.
One.
Adish?
One.
No, it would be 1.
1. Okay. So do you think it's correct?
No.
Huh?
Yes.
It is correct. Okay.
This correct?
So any
Yeah.
power of
Anything
0 is
makes
always
a
1.
power is 1.
So the way we studied power is wrong. Okay. The definition of power is 1 multiplied by n r number of times. Okay. Not the number. It's not the number multiplied with itself r number of times. It's 1 multiplied with n r number of times. Got it?
Yep.
So this is, if you see 0 to the power 0, okay, it's 1. So this is not bad. This is perfect function. Okay. All right. Now, question is, what is the order of complexity of this one?
It in looping n times or r times. So
Yes. Order of?
n.
Yes. Order of R basically, right? It
No,
basically.
that's not. Yes.
Yep. Okay. Perfect. Is everybody good so far?
Yep.
Yep.
So, I mean, it is very weird to me that I discovered that my understanding of power was very wrong while I was coding it. Okay.
Sandeep, I have a question. Like, we are going to use a couple of dictionaries like dictionary, list, vectors, right? And
Yeah.
they all
Yeah.
have their inbuilt functions like searching, right? For example. And for
Yeah.
each of those functions, there are going to be complexity as well.
Yes.
So how we can decide that which one is the best for us?
You will know. You
Okay.
will know. If you basically, if you think of all of these things like a tool and you understand their behaviors, you will be able to tell, okay, since I'm going to delete an element from a list, it's going to delete all these and it'll take this much time. Therefore, it's an order of n. Okay, so things like that. You'll get that. You'll build that hunch. Okay, you'll build that hunch. Okay. So far so good, everybody. Yeah.
Yeah.
All right. Okay. Now, I'm going to write a piece of code. Let's call it F1. Okay. Or
Sandeep, I have a question. If you run only the power 10, 0, uh, if you run only one power 10, 0,
yeah, I ran. Yeah.
no, just independently.
Okay.
Okay.
One. So what happened?
For me, yeah.
See, here the trick is that product needs to be one. Show me your code.
Okay.
Okay. Good.
Can you see?
Yes.
So what I written, define power n, 0, product is equal to 1. For I in the range of R, product is equal to product into n and return the product.
Correct.
And then I did a power 10, 0.
Oh, return is inside if you see.
Return is inside for.
Oh, because
You
of
have to
that.
reverse it.
Yeah.
But
Yeah. So
but
it entered
but
once and just exited. Yeah.
oh, because of that is because it was giving the answers for 10, 1, but not for 10, 0.
Yeah. Because in 10, 0, it went into the loop. It did not go into the loop, and therefore there was nothing to return. Got it?
Getting. Yeah,
It did
yeah.
not return. It did not return anything. Okay.
First time I started doing Python, I spent 3 days. I was doing a complex program and I'd spent 3 days debugging my code because my my one return was the way she wrote it. I spent
Yeah.
3 days finding that out.
First time that's the scenario. It's a little frustrating, but I think your time consumed in solving problem drops exponentially. First one will take like an hour, second one might take half an hour, third one might take 15 minutes, and so on. So it just exponentially drops. Okay. So no matter how much time it takes in the beginning, after a while, everybody reaches to the same level. Okay. Very important part. Now, here is a question to all. Okay. Okay. Now, how many times will this code run?
You are not sharing.
Oh,
Yeah, I think you stop sharing.
oh, yeah, it's not. Now? Oh, okay.
No, it's fine.
Here is a code. I is equal to 1, and while I is less than n, I am saying I is equal to I into 2. Every time I'm doubling the I. So let's say we say 10. So we'll say 1, 2, 4, 8. If I say 50, let's say 1, 2, 4, 8, 16, 32. What's the order of complexity of this code?
Is this n log n?
Okay, one answer is n log n. Anybody else?
And
N log n is bigger than n, right?
yeah,
Do you think it's bigger than n?
This will still be order of n.
Are you sure?
this will be order of n.
Yes, this will be order of n.
Are you sure?
Log
Yes.
n.
Do you think
This
it's
is
order
log
of
n. This is
Question
I
is
feel like
how many times will the loop run? Okay, let me ask a very, very specific question.
N
For
times, right?
for n, let's say for 1,000, for n equal to 1,000, the code was taking 2 seconds. Okay, now I have n equals to 1 million. Okay, now tell me how time equals to how much. This code, if n was 1,000, it took 2 seconds for execution. And if n is 1 million, how many times will it take? Okay, or let me make it simpler. Okay, let's see. This we'll come back to later. This is little complex. I will make it little more simpler. Okay, when n is equal to 2, how many times the loop runs? Loop runs for 1 time, right?
Yes.
If n is equal to let's say 4, loop runs for
2 times.
2 times. N is equal to 8, loop runs for
3 times. Yeah.
3
So
times.
it's a
If
table
n
of
is
2.
equal to 16, loop runs for 4 times, right?
और close करके जा.
Okay. Okay, let's take a look at the cousin of the same code. Okay, define f1. Okay, f1, and whatever is the number, what I'm going to do is I'm going to say while n is bigger than 1, okay, n equals n by 2. Okay, and I'm going to just count. Every time I'm just going to increase the counter. And I will say print count. Okay, so this f1, let's say I say 10. So it'll start, okay, let's say I say 1. So it basically loop doesn't run anyway. It is, so if the number is bigger than 1, half the number. If it is, I can also just do the print n. Okay, I'll just do the print n. Okay, let's say 5. Okay, so 5, 2.5, 1.25. Every time I'm making the number half. Okay, so for if this loop runs 3 times when I pass 5, how many times will it run if I pass 10? How many times will it run for 10?
4.
4 times? Correct? Here, you can see, here it ran for 3 times because first it halved it, came till here, and then it was 3. Now when I'm passing 10, it'll make it half, and then the problem remains like this, which is just 1 more than the previous, correct? So essentially, doubling the number is increasing the count by 1. Got it? Doubling the number is increasing the count by 1. Okay. So what do you say? No. Now F1 for 20, how many times will it run? 5 times. Not 8 times. It will run 5 times. Okay. All right. So if you plot this graph somewhere, if you plot the graph on say Desmond, let's say Desmos. Okay, let's see how it looks like. Okay, where is Desmos? Okay. So I had 5, 3 times it ran the loop, and I had 10 that ran 4 times. Then I got 20 that ran 5 times, and then I got, let's say, 40 that will run 6 times, right? Will it run like this? No. How to do this? Okay. 5, 10, 50, 20, 40. And
I think you have to give.
how to plot an array? I never plotted array. How to plot
No, I
an
think
array?
you have to give individual points, right? 5, 3, 10, 4. That's what I remember.
Let's see.
Instead of array as points like tuples, maybe.
I did the I did the tuples. No, should I do doubles? Okay, let me do doubles. This way. I just want to plot it and show you how it looks. Yeah. Yeah. So you can see this is a graph. Okay. And on one hand, this looks like, okay, right? This is a graph of log. Okay, this is a graph of log. Okay, let me now show you. Is everybody okay with this code? Before I move ahead, what's happening here? So every time I am making it half, making it half, making it half. Okay. So no matter, like, even for very big number, it'll be very small, right? Are you guys okay? Hmm. Or should I? Okay, let me see if I can explain you this way. Now let's say instead of halving, making it half, I am dividing it by 10. Okay, I'm dividing it by 10. Now, right? Let's say for n 10, it's this. For 100, it's 2. For 1000, it is 3. So you can see very clearly that this logic is just counting number of zeros. Okay. And essentially, this is essentially count is basically logarithm of the number. Log with base 10. Okay. So how many of you remember the definition of log? Right.
Sandeep, you can revise. At least I forgot.
I think the moment logarithms started, this is where most of the people actually kind of zoned out in the class. Okay. Now the interesting part about logarithms is that logarithms was invented by a mathematician and a magician. Okay. And he used to demonstrate to people that he can multiply really large numbers very, very quickly. Okay. And he used to basically just use log. He has pre-computed the multiplications of various numbers, and he used to just use the log. Okay. What is a log? Okay. Log is, let's say, if y is equal to 10 to the power 5. Okay. Okay, then 5 is equal to log of y, or you can say log of 10 to the power 5 is 5, meaning, okay, let me just change this a little bit. Okay. Okay, if y is equal to 10 to the power x and we take log, then log of y, it will come to x. Okay, whatever is the power. Okay, meaning log of 10 is equal to how much? 1, because this is essentially 10 to the power 1. Log of 100 would be 2, because we are saying log is 10 square. So whatever is the power of 10.
This
Okay.
is log base 10, right? Sandeep?
Yes. Yes. Right now, I'm only talking about something called base 10. Now you might say that, okay, why? Right? There could be log base 2, log base 3, log base 4. Okay. What does it mean? Log of 2 or 4 is same as log of 2 square. Okay. So this is, so whatever is the power of the base. Okay. So if here somebody says log of x and x to the power 5, sorry, 5 to the power x. Okay, so whatever is the base, okay, let's say this. So this will be equal to 10. Okay, basically we are counting log of something. Log of something is how many powers are there. Okay. Similarly, log 4 of 2 is how much? It's same as log 4 of 4 to the power 1 by 2. Therefore, it will be 1/5. Okay. So log essentially means we are counting the powers. Okay. How much should we raise the power? Okay. So now let's take a look what's happening in this piece of code. Let's take a look at this. Okay. So we are making it every time, we are dividing the number by 10, correct? So first it would be n, the number, then it'll be n by 10, then it'll be n by 100, then it'll keep on going and reach, say, 1. Okay. So every time what's happening is we are dividing by 10. Let's say the loop is running how many times? Loop is running count number of times, correct? So after some time, this number will reach n by 10 to the power count, which is same as 1. Now, when you solve this, you will find that n is equal to 10 to the power count. So count is what? Count is what? Count is basically, count is equal to count is equal to log of n, right? That's the definition of log. That's the definition, right? Count is equal to log of n. Make sense? Basically, the power of 10. Here, this particular log is base 10, right? Not clear? Confused? I know it has been long times to see the maths, but so essentially we say the log of anything, okay? Log of 2 to the power, log of 10 to the power 6 is equal to 6, something like that. So what power should I raise this number? Okay. So log of, let's say, how should I say? Log of 1000, and this is 10 base, okay? So you can always say log of 1000 is how much? 3. Because this is 10 to the power 3. Okay, that's the definition. That is the definition of the log. Okay, so or you can say 10 to the power log of x is equal to x. Okay, that this may look very confusing, but yeah, log is nothing but how many powers. Basically, that's how we say. Right? If we have x is equal to a to the power b, and we are saying log base a of y is equal to b. That's a definition of log. Log is nothing but the powers. So b is basically log of a base y. Essentially, this is the definition. Okay, or you can put this thing back there and you can make it look complicated. Y is equal to a to the power log a base y. No. In simple words, log is for counting zeros. Log is for counting powers. Okay. So how many times this loop runs? This loop runs as many times as a number is the power of 10. Correct? This loop, the count will be equal to the power of 10, right? If it is 100, it'll run 10 times and so on. So the complexity of the F1 is log of n. Okay? Order of log n. That's the complexity.
So, Sandeep, I might be wrong, but we are dividing it by 2, right? Then it won't be.
Then if we are dividing 2.
No, sorry. I didn't see the code. It is divided by 10.
This is 10.
Yeah.
Now let's go back to the 2. What will be the complexity of this one? Complexity is how much?
Order of log of n to the base 2.
Yes. This time we are basically dividing the number by 2, 2, 2, 2, 2. Therefore, it will keep on going as many times as the number is the power of 2. Correct? If the number is 2 to the power 100, this loop will run 100 times. Okay. So, or you can say, if the number is 2 to the power 100, the loop will run 100 times. You can see that this logic clearly. If the number is 2 to the power 1000, the loop will run 1000 times. Okay, sorry, this is 100, this is 1000. Okay, keeping the log, keeping the powers and everything aside, are you able to understand this part? If the number is 2 to the power 100, this particular code, which is dividing the number every time by 2, the loop will run 100 times. Isn't it? Are these 2 sentences correct for you? Okay.
So basically, log the base 2 of any number is how many times you can half it to go to 1? No, 0.
Yes. Yes.
Sorry, it's 1 or 0? 0, right?
No, 1.
1.
Because it will never reach 0. Correct? No matter how much you divide a number into 2, it will never reach 0.
Yeah, it will never. My bad. Yep.
Is everybody okay with this?
Yep.
Yep.
And basically that's why this has got the basically this is the complexity is log 2, which is power of 2. How much, if the number is this power, how many is the power? So log of some number represents the power, okay? Power of the base, okay? Yeah.
So can we say it's a kind of divide and conquer, right, Sandeep?
Yes, it's kind of divide and conquer.
Yeah.
Okay.
So over here, Sandeep, the base is 2, but if you don't mention the base, then it is the base 10 is assumed, right?
Here we in computing we always mention the base.
Okay.
Yeah, we always mention the base. Import math and math dot log. Okay. And here you have to, okay, let's see. Returns the logarithm of x to the given base. If the base not returns the base e, it assumes the base e. Okay, 2.3. Yeah.
No, what I was saying, like when we mention the complexity, like log n, then it means.
Yeah, go ahead.
Yes, so that means the log n means the to the base 10. Is that correct? Or maybe I'm getting confused.
Come again?
So when we say the complexity of this algorithm is log n, log of n, so that means
Yes.
it is to the base 10.
Kind of. Actually, one thing you will understand, the base doesn't matter.
Right.
Okay. Because if you plot the graph of, divide by this or that, if you remember, like log base 10 of x is equal to how much? Log of, let's say log e base, let's say we want to convert, if you remember, let's say we want to convert, let's say log 10 base to log 2. Okay. So the formula used to be convert it into log 2 base x log of 2 base 10, right? So you see, this thing is a constant number. Okay. When you say order of this is same as order of this. So, when you are reporting, you don't need to tell the base.
Okay,
because it doesn't make much difference.
Okay.
It wouldn't make much difference. Yeah. So, yeah. Log of, let's say, I'll show you. Okay. Where did it go? So, okay. Right. So this is the log of 100 base 3. Okay. And this is, base 2. Okay. This will be like a fixed number. Okay. Will be a fixed number. Right. So it doesn't matter. So the base basically is a fixed number. Okay. Like you can shift the base and just be a fixed number. Okay. So therefore it is okay to just report log and don't mention the base. Okay. While in case of math computation, by default, the base is assumed to be E. Okay. Is everybody on the same page, or have I zoned you out? Okay.
Fine.
I think I'll watch your recording once more
Go
to
ahead.
get
No,
the.
I think that
Yes. No, I
essentially
got the concept, but I guess it makes sense to watch one more time, I guess.
okay.
Hmm.
So yeah. Now, so okay, should I jump? Should I not? Okay. How many of you know binary search?
Sorted
We
order,
did
right? Like.
Okay.
we did
You did?
discuss once, right? No.
Okay. What did we discuss that time? Did we code it?
There was some example where you said that we'll do half and search it, but maybe not in detail. Yeah.
Did you code? Anybody code at that time? No.
No, I don't think we coded it.
All right. Okay, so what we'll do is, I think now is the time, because see, the concept wise, so far whatever we have learned is actually pretty good. We learned about loops, arrays, and functions. Okay, with this knowledge, we can actually implement rest of the things. Okay, therefore, even though these things exist in libraries, but it's very, very critical to know these algorithms. Okay, so the first and foremost magical algorithm is binary search. Okay, yes, I am going ahead with it. And okay, all right. Let me. Okay, so both you are ready for the challenge. Okay, all right. Think of a number between 0 and 100. Don't tell me. Just think of a number between 0 and 100. Yeah. Or Rahul, do you want to do? If...
Yep. Yeah. I did it in the last. I'll do it.
Huh?
Yeah, I'll do it. I'll do it.
Last time, did I repeat this? Have I forgotten?
No. I mean, I'm coming from the December batch, right? So
okay.
I know about binary search. Yeah.
Okay.
So
Yeah,
you
but I'm
want me to write down the
No, just think of a number. That's all.
yeah.
I
Okay.
will.
Between
Let's
yeah.
today code do it this time.
Between 0 and 100. Integer between 0 and 100. Okay. All right. Now, when I say a number, you should say your number is lesser or bigger or equal. Okay. So you have to tell me when I make a guess, I'll make a guess. You have to tell me whether my guess, whether your number is bigger than my guess, smaller than my guess, or equal to my guess. Okay.
Yep.
All right, let's start. So I made a guess, let's say 50. So is my number?
My number is bigger.
Bigger. Okay. So I will go for between 50 and 100. I will go for 75. Is it bigger
My
or
number
small?
is smaller.
Smaller. So your number is between 50 and 75. So that means this is how much? 50 and 75. Okay. And I'll just change my strategy a little bit. I will say left equals 0 and right equals 100. And my guess is going to be left plus right by 2. Okay. And I am making a guess. Okay. Now all right. And also I'll just, I'm slowly coding it up. Okay. So my guess is 50. I'm going to divide by, this is called integer division. Double slash means integer division. So like that, right? So it basically makes it near to the thing. Now, okay. Oh, I could actually make my code a little bit further better. There is this H. Okay, perfect. Now, okay. So, yeah. So my guess was when I said 50, you said it's larger. So I'm going to say the left is going to be guess plus 1. Okay. And now my guess is 75, and you said it is less than 75, right? Your number?
Yes. Yes.
Less than 75. So that means that my right hand side, I am going to say guess minus 1. Okay. Again, I run 62.
It's less than 62.
Less than 62. So I will call this one guess less than, right hand side will be less than 62 now. Okay. Then again 56.
It is less than 56.
Less than 56. Okay. And I will also print my left and right just for debugging. This is my left. And okay. Right. This is my right. Okay. So 56, you are saying that your number is less than 56. Okay. So I'm going to again say that right side. Okay. So now between 51 and 53, it is saying 55, it is saying 53. Is your number less than 53?
Yes.
Okay. All right. Okay. So is your number 52?
It's 51.
51. Okay.
It's 51. I think
50.
the guess is 51, right? So it's right.
Yeah, okay. Perfect. All right. So this is how we did the guessing. Okay. Now notice very closely what's happening here. What's happening here? So initially I had a range to guess from 0 to 100, correct? First time. And as soon as I guessed the 50, right? Now, and he told me that this range, like the number is bigger than 50. So now my range in which we have to guess the number has become this, right? So every time you can see this became half every time. And then when I guessed 75, right? And he said it's less than 75. So it basically became this. So you can see every time the range is being halved or is, divided by 2. You can see that. So the range of numbers is turning half and half and half and half every time, right? So, and like this, it'll reach 1 at the end of it, correct? So what is the order of complexity of this search? This is strategy. Every time it's halving.
Log n.
Log of n to the base 2.
Yes. You just say log of n. Okay. So whatever is the range, okay, like if the range was 200, I will need one more iteration because 200 divided by 2 will become 100 in a single shot. Correct? So, are you guys okay with this? No. Everyone?
Yes, Sandeep,
Yes,
quite good.
yes.
Okay, perfect, perfect. Now, right, you might say that, okay, binary search exists in the library, then why are we coding it, right? There are so many beautiful problems, and every interview of every FANG company or any top company, right? First 2 rounds would involve one binary search questions, okay? And it's no secret, it's a reality, okay? And binary search problems occur in many, many, many ways, okay? Like, for example, computing square root, okay? How would you compute a square root? Anyone? The square root of 10. Yes?
Similar to what we did for the power, we divide
Yes.
it by
So what we'll do is, let's say our number,
1.
okay, right? Our guess is, let's say, okay, I'm going to just use the same code, okay? So I'm saying that let's say whatever is my number left equals 0 and right equals 10, okay? So my guess is this. Now I will also print guess square, okay? So what happened here? Oh yeah, this is one bad habit I'm not able to overcome from my C or Java days. Okay, so 0 goes into the left and right goes into 10. I'm saying guess is equal to midway. So I said, okay, guess is 5. Okay. Okay. And I'll say, okay, guess is 5. And I'm basically saying print a square. Okay. A square is guess times guess. Okay. So I guessed 5. Let's say the square root of 10 is 5, but 5 square is 25. That means my square root has to be less than 5, correct? So what would I do? I would say right side, okay? So I'll say, okay, don't go beyond 5. So I'll say right side is 5, okay? Right side is equal to guess, okay? Now, again, I do that. Oh, I did this, right? Guess, okay. Yes. No. Here I'm making a mistake. Okay. So initially, basically I said, okay, I have to find the square root of 10, right? So I said, okay, let me choose a number which is the middle of 0 and 10. Okay. And it turns out to be, say, 5. But square of 5 is higher than 10. Square of 5 is higher than 10, which means my square root of 10 is going to be less than 5, right? So I'm saying that, okay, right side now becomes my 5, okay? Right side has become 5. So I'm just removing this thing, okay? So now, again, I'll start. Okay.
Sandeep,
Now,
I have a question here. Why we have a double slash, and now we have a
that's
single
for
slash?
integer division. That's integer division. Yeah. That was for integer, because we said in the problem that we were having earlier, we said that we will only do the integers. Okay. the guess has to be integer because it was a integer. That was the prompt statement. Okay. Are you with me, everyone, so far? So the way I'm computing the square root is by the way of guesswork. Okay. I'm computing the square root by the way of guesswork. Okay. So I said left comma right equals 0 comma 10. And I'm printing left and right and computing the guess, left plus right divide by 2. And it says, okay, your guess is 2.5, the square is 6.25. That means it has to be higher than 2.5. So I'll say side now is my equal to guess. Okay. And I go back here. So 2.5 and 5. And the guess is 3.75. Square is now 14. So what I say, okay, this is too much. Okay. So my right hand side will become like this. And then, so now I'm searching for a number which is higher than 2.5 and lesser than 3.75. So I said, okay, let me pick the mid value, which is 3.125. And the square comes out to be 9.76. So which is actually smaller. That means our number is going to be towards the right side of this. Okay. Towards the right side of this. So what we'll do is we'll search for a number between 3.125 and 3.75. So what we'll do, we'll assign the left equal to 3.125. Now we are searching for between a number between 3.125 and we're picking the center of this. And it turns out to be a little bigger. So we'll say, okay, this guy, let's, instead of searching between left and right, we are searching between left and the guess. Okay. So right becomes guess. And again, we do that. We are now, the guess is 3.28. Okay. And now we are saying that the square of 3.28 is 10.76, which is actually close to 10. So we are reaching nearby the square root of 10. But this is little bigger. So I'll search for something between these two numbers. So right equal to guess. And then we go. Okay. Then again, right equal to guess. Then again, then right equal to guess. Then again. All right. This time the number is less. So I'll say, okay, choose something bigger than this. Okay. Okay. Again, it became smaller. And again, it is smaller. Okay. Smaller. So almost there. Do you see that? Now you might ask, when should we stop? Okay, the answer is when we are tired. Okay, so essentially we just say that, okay, the tolerance limit is this much. And if basically it is within the toleration limit, we should just stop. Okay. Would you be able to code this, everyone?
Yes.
Okay. I want you guys to try coding the square root. Okay. Coding the square root is much easier than searching a number in a list. Okay. And therefore, I want you guys to code the square root. Okay. Whatever we did manually, okay, we are going to do you should do this process using the code. Okay.
Okay.
Now, so assignment for all is code the SQRT. Okay, that's the first assignment. Okay. Now, can you extend this program to code the fourth power? Okay.
NQRT basically. Okay.
And code the fifth, sorry, 1/4 power. Okay.
Yep. 1 by 4 square root, right? Like
1 by
cube
fifth
root
power.
or quad root. Yeah.
Okay. Using the same mechanics.
Generalize it basically, right? That's what you meant to say.
Yes. Okay. You might say that, you know, wouldn't it be very easy rather than jumping back and forth and doing all of this? Wouldn't it be easier if we just scanned the data from this side to this side? Okay. Couldn't we just do the guesswork from this side to this side? We can. But the problem is it'll be how much? Let's say let's say we are writing this code. I equals 0 while I less than let's say 10. Okay. If okay, if I times I is bigger than 10 break, okay, and print I. So I'm saying this break means the loop will break, okay? This loop will break, okay? And else I plus equals to 0.01, okay? Now, tell me, what is the order of complexity of this? How many times this loop will run?
100,000 times actually.
So it is running how
It
many
will
times?
run till.
I think it's running like an infinite loop, right? Doesn't look like infinite
At least
though.
1,000 times. Now, it will. No, we are not incrementing the value of 1, so it would be. Yeah, I mean, we are not assigning the value back.
I forgot
So,
this.
so it would be.
Yeah.
No,
Yeah.
that's right. Yeah. It would run.
Okay.
It would run for, yeah, it would run for log of that number divided by 0.01. That many times.
No. Okay. So it found this kind of accuracy, but not very good. Okay. And how many times did it run? Every time it's starting from 0. Every time it's increasing by this much. So how many times will it run?
100 into 10.
So till the log of the given number multiplied by divided by 0.01.
It'll run
That many increments, right?
1,000 times,
I think
right?
square root of 10 divided by 0.01.
No.
Square root of n divided by 0.
No, it won't. So
Yeah.
see the order of complexity, if you think about it, okay, what is the worst case? Okay, it's basically this one. Yeah. So basically it is the how should I say? Yeah, you are right. It is kind of this divided by this, right? 316
Yes.
times. This is what you meant, right? So yeah, you are right.
Yes.
So it'll run for this much time. Okay. So it's actually pretty rigorous. And the moment you try to improve your accuracy, right, it will suddenly start becoming bad. And the moment you say, okay, 1,000 number, okay, and you want to, let's say you are looking for the square root of, let's say 1,000 number, and you put n here 1,000, okay. So it basically would start becoming slow, okay. You can see it has already become so slow, right? So the moment your complexity increases, it basically has become super slow, right? While on the other hand, the square root that we did above, you know, it will be pretty quick, okay? It will be pretty quick, okay? It will reach to the actual square very quickly. Okay, you can do this calculation. Okay, is everybody okay with what we did today? Everyone?
Yes.
Would you be able to code square root with this technique? So
Square root using binary search, right? That's what you're saying.
yes.
I'll try.
Square. So this is an iterative method. This is an iterative method to find the square root. Okay. I am saying that try doing this simple experiment that we take a number between 0 and 10, square it, check if this is high or low, then our target. If it is higher, then only search this side, otherwise search that side. Okay.
Yep.
All right.
Yeah. Is this exercise for today or for next week?
It'll be
tomorrow class.
Binary search. Okay.
Yeah.
So now
Yeah.
the same problem can be extended to so many hard problems. Okay, so many situations you can solve. Whenever you have a clear correlation that, okay, should I go left or right? You can use binary search. Okay. And you can also calculate the log of a number. Okay. You can calculate the log of a number using the binary search. Okay. Because opposite of log is the power. Okay. Right. And like let's say 10, the log of 10 is 1, right? So we can let's say I have to calculate the log. Okay, I can do the exact same story. Instead of multiplying, I can just say I can just say that, okay, do the log. Okay, do the power. Okay, check the power if it is the actual number or not. So you can do the binary search in the game. Okay, and this is a fun exercise, and you can actually do it with your kid, with anybody, and it's actually is a very important exercise. Okay, I have done this with my kid, and I found that they were able to he was able to handle it. Okay. And yeah, so I think you can just create like a quick kind of a thing where let them uh think of a number and you make a guess, and then you think of a number, let them make a guess. Okay. And that way you will understand the binary search better. Okay. So all right, so we talked about the binary search. Okay, it's a good digression. I wanted to cover it. Okay. And now this way we learned two things today. One is big O notation, the order of complexity, and the second is binary search. Now, let me go back to the problem statement that is already hanging. Okay. All right, where were we? Good, very good digression. I think we are doing pretty well, and we are going very well so far. Okay. So I did a coin toss of the end phase thing, right? Now the next thing is the biased coin, right? Biased coin. Okay. What is biased coin? Biased coin is about, let's say there's a coin. I want head, let's say 80% of time, and I want tail 0.2% of time. So what I do, R equals random. If R is less than 0.8, I return 0, else 1. So that way it has become the, okay. Where did I make mistake? define coin. Oh, okay. These are the probabilities, right? Okay. So here, when I say coin cost, and I'm saying 0.8, 0.2, it's basically giving me 1. Okay. All right. Now, let's say I want to do this 3. There are 3 values. Okay. Coin x1, x2, x3. There are 3 faced coin, and I want to make it such that, okay, random. So this is already done. One of many of you have already done it. So I'll say if r is less than x1, return 0. Else, if r is less than x1 plus x2, return 1. Else, return 2. Okay. This way it will do like a random coin. I mean, biased coin flip. Okay. And yeah. Did I make mistake? Yeah, it's actually working. Yeah. So you can see that this is a biased coin. Okay. Instead of going with the best probability, it is basically giving us a probability of that particular number with a higher probability. Okay. Is everybody okay with this? Yeah.
Yep.
Perfect. Now, let me ask the next thing. Okay. Let's say let's say somebody gives me an array like this. So all I will do is I will start from left. I will add all the values in the array, and that's it. Correct? So I'll say I equals 1. Okay. And I'll say for I in range. Okay. Or we can just say while I less than length of array, I'm going to just say I array at I is equal to array at 0. So what I did was I did a cumulative calculation. Okay. I said, okay, if somebody gave me a probability 0.1, 0.2, 0.3, and 0.4, right? If somebody gave me these probabilities, then I have basically converted them into 0.1, 0.3, 0.6, and 1.0. Okay. So if the number is less than this, I return 0. If the number is otherwise, if the number is less than this, I return 1. Otherwise, if the number is less than this, I return 2. Otherwise, return 3. Okay. So what is it that I'm doing? Okay, that's about it. Now, I would say that, okay, what would I say? All right, for I in range, okay. All right, I in, what is it that I'm trying to do? I would go over this array of probabilities. Okay, so I'll say for I and value in enumerate array, if v less than r, return I. Otherwise, okay, that's it, right?
Sandeep, I have pasted one code. Maybe it's almost similar.
Okay.
Sorry, what is R here?
Oh, what is R? Thank you for telling me that. I assumed it to be. Yeah. Okay. So whatever we did here is this. Essentially, what I'm trying to do is I am saying, okay, I'm saying, let's say somebody gave 0 0.1, 0 0.2, 0 0.3, 0 0.4. Okay, meaning 0th phase should come only like 10% time. 1 should come 20% time. 2 should come 30% of time. And 3 should come 40% of time. So what I'm saying, okay. So if you divide this number line into something between 0 and how many is total? 1, right? 0 and 1. So this size is going to be 0.1. This size is going to be 0.2. And this size is going to be 0.3. And this size is 0.4, right? So what we want is that 10% time this number, 20% time this number, 30% time this number. And so we will basically, what we'll do is we'll throw our random number and check where is it. Okay, where is it? All right. So there, I don't think you can do without the loop. You'll need a loop because you have to go through the probabilities. So I'm saying that if the number ends up here, okay, the random number, okay, return 0, okay. If random number ends up here, return 1. If random number ends up here, return this. Okay. All right. I have actually imported, the random has something called random. So you can say from random, import random. Okay. So random is a function, random is a module. Everybody okay with me so far?
So Sandeep, will this work if, I mean, the example you took, the total was 1. Will it work if the total is not 1?
Will it work? Okay. Yeah.
For example, will it work
Yeah,
for...
very good point. Very good point. It won't work if the total is not 1. Okay. It won't be good. It won't be good. It'll make mistakes if the total is not 1.
Probability of 2 digits are same, then
it can give either.
Okay.
Okay. So what we are trying to do is we are doing an unfair coin toss. Okay. So like, for example, how is this related to what we are discussing, right? How is it anywhere? It might sound like a fantasy problem that I have created, but it's not. Okay. Let's look at the practical application of it. Okay. Think of a large language model like ChatGPT. Okay. Everyone. So what does a large language model predict? Large language model, you feed a sentence to it, your question. Okay. And in one single shot, it gives only one word. And how is this one word represented as numbers? It gives a probability of next word suggestions. Okay. So if you have a dictionary of 10,000 words, okay, it will give a probability that, okay, 0.1 times hi, 0.2 times hello, and 0.4 times, right, how, right, like that. Okay. So 10% of time hi, 20% time hello, and 40% time how, and rest are small probabilities. Correct? So an LLM produces these probabilities. Okay. Now, your role is that given these probabilities of the words, you want to pick a word from it. Okay. And instead of just picking the the highest value, you want it to be a little bit more serendipitous. Okay, because what would happen if, let's say, this has two words with equal probability, right? If you only pick the best word, you might always pick hello and not how, right? So what you want is that 40% of the time it should end up here, other 40% of the time it should end up here. Okay, that's why if you run ChatGPT like multiple times, it gives you multiple kind of suggestions, right? It is based on this kind of selection. So what you want is, given this list of words, pick the word a little more randomly, but in the same ratio or probability as their chances given by the large language model. Am I in the context or have I lost you? Please go ahead. Is it making sense or is it just too advanced? Do I need to slow down?
So it's like every word when the chosen, then it has list of all the possible values with their probability, which will come next, right? Something similar to what when we are maybe not same, but something similar to what when we are typing on our phone, right? It actually gives us list of words which may come in next.
Exactly.
Based on what you have written.
Exactly. LLM is essentially like a autocomplete keyword. ChatGPT is essentially this. Given a question, predict the probabilities of next word. Okay. So LLM gives out the probability of next word or next letter. Some models work on next letter, some models work on next word. And ChatGPT has chosen a way between the two. They call it tokens. Okay. You can think of that as a syllable. Okay. Now, what I'm talking about here is a very important part. It is essentially given the output of an LLM, how would you choose the words with the same chance as their probabilities? And you can't do max, because if you do the max, what happens is you will end up making stupid mistakes. Because imagine the two words, one is 0.5 high, let's say 0.49 high, and 0.51 hello. So you will end up picking only the best. You'll end up always picking hello as the next word. Okay. And so this taking the chance is called serendipity. Taking the chance is called serendipity. Okay. Everybody okay with this?
That means, Sandeep, so in the maths, if we go by the maths equation, so it will be a rule-based model. If we go by, but if we go with the LLM, it will be more probability specific as output.
So yeah, LLM will give us the probabilities, but selection of that word is basically a little more serendipitous. Okay, based on the probability. Yeah.
No, but then why? Maybe a dumb question, but why exactly we want to do that? If the probability of a word is higher, shouldn't we choose one? I mean, for example, here it is too close. But if, for example, there are only two options where the probability of next word is 99 and the other is 1, why would we ever choose the one with probability 0.01?
Right. So there are many reasons for it. First is, you must have seen in ChatGPT that if you say that, okay, this is a incorrect answer, it gives you an alternate answer, right?
Yes.
So basically, and same question you asked twice, the chances are it'll give you different answers. Okay. Basically, and then when you are rating it that, yeah, this is a better answer than the previous one. So what is happening? The ChatGPT is learning from that feedback, saying, okay, I basically showed this answer to this person. He gave to this as a star, but when I showed this answer to the other person, it did not work. So one is you get to explore more world. As I gave the analogy last time about the idli and dosa, that you want to eat 90% like your uh you are how should I say, you are longing to eat dosa 90% with a 90% probability. Your interest is 90% while eating the idli is 10%. Now, if you never eat idli, you never get to explore a food, a new food, and hence the preconceived notion becomes the truth because you never tasted idli. Okay, therefore, in every model, every AI model, there is a good amount of serendipitous, or you can say exploration probabilities that we want to do. We are building a robot. If it's only doing the same thing over and over and is not taking a bit of chance, what it'll do is it will not learn new things. It'll just be bound in that. Similarly, if ChatGPT does not generate alternate answers, it won't get to learn from your feedback which word is better, right? So the common sense would be that, okay, let's just choose the best word, but the answer is not right. Okay. And sometimes even there is a slight bit of difference. One is 0.49999 and other is 0.498. Now, which one should you choose? If you're choosing only the first one, you are being biased because this is basically both of them have the equal probabilities. Okay. So you always keep this in mind, that make sure that you have you basically you utilize this coin toss mechanism. Okay. And every algorithm out there in ML utilize this coin toss. Okay. This kind of a coin toss. All right. Am I making sense, everyone? Subodh was able to answer your point.
Yes. Yes.
All right. We will continue from here. So we were able to code the randomness. Okay. And yeah. So
I loop array of I plus equals to array of 0. I think
uh,
it is not incrementing.
which one? Oh yeah, thank you. It's not incrementing. This one, right? Yeah. Yeah, I think you can fix this code. For I equals to 1, I less than length of array, array of I. Oh, this should be I minus 1. Okay. All right. I equals I plus 1. This is correct, right?
Array of I minus 1. For 0.4, it is adding only 0.3, not 0.1, 0.1.
No, it will be accumulated, right? So, see, it will start from here. Okay. So this value will become 0.3, correct? Then it'll come here. So 0.3 plus 0.3, it'll become 0.6. Then 0.4, because I'm replacing and updating this array in place. Okay. You can take a look here. Print array. Okay. So 0.1, 0.3, 0.6. Right? Okay. All right. Let's see. No. It'll be the other way. Sorry. Yeah, this is better. So if the random number is within this value, then it'll return that. Got it?
Not relevant, but isn't this calculation wrong in the sense the way Python is doing it? 0.1 plus 0.2 should be 0.3, not 0.3004.
Yeah. So yeah, this much noise is there. This much noise is there. Okay. I think in floating point, you have to be very careful, therefore. You have to kind of always, when subtracting, comparing, you should always use a tolerance. Okay. Now, so this seems to be okay. And I'm just going to comment this out and test it out. Okay. Let's see. If, let's say, these are my probabilities. Okay. What is the way to normalize an array? Okay. Or let me say convert to probabilities, right? How would you do if this is an array? How would you convert it into probabilities? Like weights are given. Let's say weights are given. Relative weights are given 10, 20, 30. So you want to convert them into probabilities. What will you do?
The number divided by sum of all the weights.
So we can say, yeah, code it up. Okay. So yeah, this is a question. Okay. So this is a question. And okay, so where is the assignment for today? Okay. So this is one assignment. Okay. The question number 4, convert to probabilities. Okay. This should become something like 10 divided by 10 plus 20 plus 30. Okay. So do that. So convert it into probabilities. Okay. And yeah. Once you have done that, right, use the another technique called we call that softmax. Okay. Softmax. Okay. And this is another question. Question number 5. Okay. This is called softmax. Okay. What we usually do in this case is, let's say we are given 1, 2, 3. Okay. So what we will do is we will say 10 to the power 1. Okay. And 10 to the power 2. And 10 to the power 3. And then we will use this convert to probabilities method. Okay. So what we are doing is we are making each number as a power and then dividing by the total sum. Okay. So do these 2 problems and observe what happens in case of softmax. Okay. This is called softmax. If let's say somebody gives you 1, 2, 3, you make it a power of 10. Okay. We are taking the 10 just for the example here. And you convert it into probabilities using the same method. So first you do each power, like 10 to the power 1 is 10, 100, and 1000, and then you convert it into probability. And observe that if we do the softmax on an array and then calculate the convert into probabilities, what happens to the number? What does softmax do the softmax does to the numbers? Okay. So we'll talk about this tomorrow. And yeah, but I want you guys to code it up. Okay. So is the Are these problem statements clear to everyone?
Yes.
For
But
sorry, for the
For
softmax,
sorry, go ahead.
Yeah, go ahead.
you go ahead.
Okay.
okay, I'll go ahead. For softmax, I mean, it's just raising it to the power of 10 and then doing the same kernel probability, right? I mean, just
Yeah,
trying
yeah,
to.
yeah. Internally calling this function.
Okay. Okay.
Okay. These are super simple things. Okay. These are super simple things. It only requires a simple for loop. But the reason I'm bringing these in is when you see these things and later, you will not have a single confusion. Okay. It'll build an intuition in you. Okay. It'll build an intuition. Okay. Also, yeah, we talked about the order. I would say practice, try answering the order question on every of these piece of code. Okay. Try calculating the complexity of all of the above code. Okay. Whatever you code, you should test, try to figure out the complexity. Okay. And report like this is my order. Okay.
Sandeep, just one question. So for let's say the weighted n dice, would the order of n be O of n square, since you're using 2 for loops?
Where the weighted
This one, IN 171.
Good question. Good question. This one, right?
Yeah.
So see, if let's say the size of array is n, correct? So first loop will run n times, right? N minus 1 times actually, correct? And the second loop will run how many times? N times. So it's actually close to twice n times. Okay. And order of like big O of 2n is same as order of n. Okay. Got it. It is not one inside the other another. If the loop was one inside another, then it becomes like multiplication of the two loops, right?
Okay. Okay. Makes sense.
Here, first one finished n times, then second one n times. If it was one within another, then it'll keep on looping, right? Then it becomes n square.
So basically any linear increase in loops, right? We consider as order of n.
Exactly.
Unless we know exactly what it is.
Exactly. So this is the hunch I want you to build. That, I mean, you should be able to describe the way you have done, the way Subodh has done. Everybody should be able to describe it. Okay. So I want you guys to experiment and practice. Okay. All right. And yeah, I hope, I think, see, except for these first, so question number 1, 2, and 3, all are same problem. Question number 4 is actually pretty simple. Question number 5 is again very, very simple. Okay. So you can finish these, like if you finish this one, rest is all done in a single shot. And it'll be super simple for you. Okay. I'm going to just commit this code right away. Okay. Git diff. Okay. This is the code. Git status. Okay. Modified git commit 24 May. Okay. So I'm writing that. Okay. Added the exercises and code in previous notebook itself. Okay, so this is called a git in which so I made my changes, I committed, my changes went to the central repository where you can see my changes. Okay, my changes have come here. Okay, So this is today's notebook, right? 11th May. This is that. Okay. Not this one. Not this one. Not this one. Not this one. Today's 2 hours ago.
No, I think you have updated 24th May.
Okay, okay. No, I did not commit. I did not commit. Yeah, I have to do one more step. So after committing, you have to do git push. Okay. All right. That's it. So if you guys are new to Git, all you need to do is git clone and go to this repository here. Click on code and go to HTTPS, copy and paste. So this command, if you run, it will bring these notebooks into your home directory. Okay. And then when you go here, you will see, you will be, when you go to your Jupyter, you will see this folder at the top. Okay. And that's pretty much.
Sorry, can you share the last commands to add it to our Jupyter? I mean, I do it to local. I don't know. Okay.
I shared. All right. Thank you, everyone. And this was wonderful. I hope these sessions are good and helpful to you. And yeah, I'm going slow, but I think in case you find it fast, please let me know. Please stop me then and there. Probably if you are facing problem, other people will also be facing the problem. Okay. So yeah, please, feel free to stop me at any point of time. And I swear I won't take an offense. Okay. And
thanks, Sandeep.
All right. Thank you, everyone. Have a good day.
Thanks all.
Thank you,
Thank
Sandeep.
you.
Bye-bye.
Thank you.